Everybody, welcome back. Lesson 3, Rational and Irrational Numbers, the Real Number System. So real numbers consist of two types of numbers, as you can see in this visual. Real numbers, the blue, has this huge box. It includes rational numbers and irrational numbers. You have probably experienced in most of your early elementary career natural numbers or whole numbers, which are our, whole numbers, 1, 2, 3, 4, 5, along with 0. And around middle school, you probably got introduced to integers, which are numbers that have negatives, so negative whole numbers. And then finally, rational numbers. You've probably experienced fractions or numbers that can be written as a ratio or including decimals and fractions. And then finally, we were talking about irrational numbers. A lot of times when you have a square root and it is not a perfect square, you're going to have something called an irrational number. We're going to talk about that. But first, you're going to play a game, and based on that game, what can you determine about rational numbers and irrational numbers? Your job is just to play the game for a little bit and jot down some notes in this empty space on your worksheet. Once you're done with that, then we'll go to the next slide. So you might want to pause the video at this point and play the game. To continue this lesson, you're going to copy down some definitions and some examples of these terms. So let's start with that. It's up to you if you want to copy it all down first and then watch the video of me explaining it, or vice versa. You can listen to me explain it and then copy the notes after. It's up to you. But at some point, you're going to want to pause the video and copy these notes down. Make sure you have them down correctly, as well as the examples. All right, so rational numbers. Rational numbers can be written as a ratio. Obviously, that's where the word rational number comes from, rational ratio, which really just means fraction. If you recall from like 7th grade, ratios can be written in 3 different ways: 1 way, 2 ways, 3 ways. But fraction is 1 way. So if it can be written as a ratio with 2 integers, then it's a rational number. Obviously, that includes fractions, because fractions are a ratio. Some decimals, so a terminating decimal or a repeating decimal, like those guys down there. Whole numbers, any whole number can be written as a fraction. All I do is just divide it by 1. And same thing with an integer. An integer is just a number, could be positive or negative, so let's pick a negative one this time. And again, I could just rewrite that as a ratio over 1, and that will be the same as this. So those are our rational numbers. A terminating decimal, which is also considered a rational number, is technically a repeating decimal with a repeating digit of 0. Terminate means end. So let's just focus on that definition. It means this fraction, this decimal ends, this decimal ends, this decimal ends. If they end, then they are considered a rational number, and I can write them as a fraction. So for example, in this problem, I would read this as 5/10, and it would just be written like that. The way I read it correctly, with correct math terminology, would be the way I would write it. The same thing with this number. This is technically 234 thousandths, so I would write it as a fraction like this. But again, any decimal that ends or terminates is considered a terminating decimal, which is a rational number because I can write it as a ratio. So this is also a rational number. Make sure you copy not only the notes, but also some of the examples down as well. Finally, a repeating decimal is also considered a rational number, a decimal that repeats with a pattern. These can be written as fractions or as a ratio, right? Ratio, rational. So if you get in your calculator 0.33333333, the calculator will not show these dots at the end, but you might be able to assume that it is a repeating decimal. One way to check that is to see if you can turn it into a fraction using your calculator. Again, if you're not sure how to do that, look at the calculator videos that I have on fractions. If I type that in and hit second fraction decimal, right, I should be able to get the fraction 1/3. That's how I know that this repeating decimal is a rational number, because I can write it as a fraction. Another thing you're going to note is if I want to write this as an answer, another way to write this as an answer is this with something called bar notation, which you had talked about in previous years, but I wanted to review here. I use the bar over any digit that is repeating. So for example, if I have the decimal 41, 41, 41, and it just keeps going and going and going, I can shorten that by writing 41 with a bar over it to show that the 4 and the 1 are repeating in the pattern. So those are equivalent. My dots did not show up. There we go. Again, pause the video, make sure you have all of the notes, the definitions, as well as the examples copied. Last definitions to copy. Obviously, we're now talking about an irrational number, and there are only one type. So an irrational number is a number that cannot be written as a ratio of two integers. Cannot. These really just include one type that we're talking about this year, which are these guys, non-terminating, non-repeating decimals. Whew, it's a long definition, but it basically is just saying a decimal that continues on forever with no pattern, and it will never end. So that's it. It does not end, and it has no pattern. Those are really the two parts to the definition that you need to include, especially if you're going to explain that a number is irrational. So for example, if I type in my calculator the square root of 2, I get this giant, I like to call them giant decimals, 4, 1, 4, 2, 1, 3, 5, 6, 2. That's all my calculator says. Notice you see absolutely no pattern in the numbers. They're not going, it's not 333, it's not 414141. It's just a whole bunch of nonsense numbers in no particular order. Obviously, your calculator stops here, but in reality, your calculator kind of stops after a certain number of digits. So unfortunately, if you see a number like this, and the decimal goes on and on and on until your calculator ends, this is considered an irrational number. And again, it's irrational because it has no pattern and it will never end. So it has to have those two definitions, those two parts of that definition to explain why this is an irrational number. It's irrational because it has no pattern and it will never end. Make sure you have both parts of those definitions as well as my example written in your notes. We'll see you soon.